Good morning, everybody. I am starting my lecture series on anesthesia workstation. Now I come to oxygen fail-safe device. In the Detex Omida machines, the nitrous oxide is always connected to its flow meter through an oxygen fail-safe device. This device has a spring-loaded valve. Oxygen pressure acts against the force of the spring and keeps this valve open so that the nitrous oxide can flow to its flow meter. Once the oxygen pressure drops below 30 psig, 205 kilopascals, kPa, the unopposed force of the spring shuts the valve off and nitrous oxide can no longer be administered. In some machines, air supply also flows through a fail-safe device. However, some manufacturers allow air to be delivered directly to the flow meter. This will enable the anesthesiologist to administer air in the event of oxygen failure. Modern machines incorporate an electronic switch which will not allow air and oxygen to be used at the same time. Oxygen failure protection device. This device used in the Drager's machine proportionately decreases the nitrous oxide pressure based on the oxygen pressure. In the oxygen fail-safe devices, the flow is all or none. In the oxygen failure protection device, the flow is proportional and is variable and maintain the desired level of FiO2. Only at extremely low oxygen pressure, the nitrous oxide flow is cut off. Proportioning systems. Newer machines are equipped with proportioning devices which ensure that a minimum FiO2 is ensured at all the time. Detex Omida, the flow meter controlled valves of oxygen and nitrous oxide are mechanically linked with chains. Normally, both the knobs can be operated independently. Whenever the proportion of oxygen approaches 25%, the gear engages and both control knobs get engaged simultaneously. This mechanical system is supported by pneumatic system whereby both the flow meters operate at different pressures due to the differential setting in the respective second stage pressure regulators. The resulting combination ensures a minimum FiO2 of 25%. The Drager oxygen ratio monitor controller. Oxygen and nitrous are interlocked pneumatically to ensure a fresh oxygen concentration of at least 25% plus minus 3%. The pressure downstream of the flow control valves of nitrous oxide and oxygen and upstream of the resistors before the flow meter tubes are linked through pressure transducers. This system controls the slave control valve, which controls the oxygen inlet pressure. Now, oxygen low pressure alarm. The low pressure or oxygen supply failure alarm will go off when there is a significant increase or decrease of the oxygen supply pressure. This occurs when there is a sudden loss of cylinder or pipeline pressures, or when the anesthesia machine is turned off or on. A commonly used mechanism utilizes a pressurized canister that is filled with oxygen when the anesthesia machine is turned on. The system of oxygen that the stream of oxygen that goes into the canister passes through a whistle, and a sound can be heard when the machine is turned on. If the oxygen pressure then falls below a certain value, this canister will empty and direct a reverse stream of oxygen through the whistle. This alarm may not be heard if the oxygen supply pressure drops very gradually over a long time. Some machines have a visual alarm as well. The audible alarm should be activated within a few seconds after oxygen pressure drops below 200 kPa and have a minimum noise level of 60 decibels at 1 meter. The alarm can be switched off only by restoring the oxygen supply. Now the flow meters. The flow meters of oxygen, air and nitrous oxide are measured by flow meters and are supplied to vaporizers and CGO, that is common gas outlet, from the fresh gas assembly. Presence of carbon monoxide, carbon dioxide and cyclopropane flow meters in the machine is of historic interest only. Based on the controlled flow and measurements of flow rate, they are classified into traditional, that is Omida, Dragar, like that, or hybrid, that is Datex, Dragar, etc., and electronic, that is GE ISIS. Thank you. This much for today. Next, I will come with more information in the lecture series.